Okay, for what we're going to do today as far as graphing nonlinear inequalities is going to be easier done in what's called interval notation. We haven't seen this before, so I want to bring it to your attention what interval notation is. It's a way of describing a region on a number line. Every number line begins at negative infinity, ends at positive infinity. And what an interval notation does goes from a small number to a big number. And it can have either a parentheses or a bracket. A parentheses means do not include this number. A bracket means include this number. So if I want to graph negative infinity to 3, and negative infinity is all the way down that way, 3 is right here, all right? The 3 has a bracket, and I want to include 3 as in my answer, so I'm going to put a closed circle to represent that bracketed 3. And I want to go all the way down to negative infinity, so I would shade off this direction and shading my arrow to demonstrate it goes on all the way to negative infinity, like so. So interval notation, negative infinity to 3, bracket means that. Alright, if you take a look at the second one, we're going from 2 parentheses to infinity parentheses. Oh, by the way, infinity always gets parentheses because you can't include infinity. Infinity is not a specific number, it's an idea. So I always put a parentheses on infinity. But if I'm going from 2 to infinity, I'm going to put an open circle at 2 because it does not have the bracket. It means do not include 2. And I'm going to go all the way to infinity. Infinity is over here, so I'm going to shade off this direction and make the arrow nice and bold going that direction. Okay. If there's no infinity involved, there's just from number to number, negative 1 bracket to 3 parentheses. Negative 1 bracket means that we're going to put a closed circle at negative 1. Parentheses on 3 means we put an open circle at 3, and I shade between, like so. Bracket 0 to bracket 2 means closed circle on 0, closed circle on 2, shade in between. All right? And that's all that all means. It's just a way of demonstrating those regions. Negative 1, the way we would have done this before, negative 1 less than or equal to x is less than 3. That's what that one looks like, right? That means the same thing. And these are just a little bit easier to write, so if you get comfortable with interval notation, that'd be the way to do what we're going to be doing today. Okay. And anytime you want to use interval notation to demonstrate that type of answer, if you wanted to say that answer and you wanted to write it that way, I'd be fine with it. It means the same thing. One other thing they're going to throw at us today will be domains. So let me just throw in some domain issues on these two here. Okay, we saw what they look like without domain issues, just real numbers. Okay. Suppose I want the domains instead of integers. All right. So negative 1 to 3, only integers count. So negative 1 bracket means negative 1 gets graphed. Negative 1 is an integer. 3 parentheses means 3 doesn't get graphed because open circle at 3, we don't have open circles in the integer world, right? I want all the numbers between negative 1 and 3 that are integers, so I would graph 0, 1, and 2 also. And that's what the graph would look like for that if the domain is a set of integers. For this one down here, suppose the domain is a set of negative integers. Right? What negative integers are between 0 and 2?
No.
None of them, right? So there's your graph right there. All right? That can happen. So if I said positive integers, notice 0 is not positive, right? It would be included in that region from 0 bracket to 2 bracket. That means everything between 0 and 2, including 0 and 2. But 0 is not positive, but 1 and 2 are. So now I would just graph these two and I'd be done with it. So again, all the domain does is it takes what your normal answer is and just filters out some of the answers and only gives you the ones that you want. Okay. So with that in mind, let's take a look at the problems that we're going to deal with today. All right. This is where you want every problem to be before you start worrying about graphing anything. All right. You want it factored form, inequality 0. And let me just say this. Less than 110, less than 112, they're exactly the same skill. Less than 110 has greater than 0, less than 112 has less than 0. They're the same skill. They're done the same way. I don't know why the book decided to put them in 2 different lessons. I decided to teach them all the same day because they're the same kind of problem. They're done the same exact way. Everything's the same. All right. So We're going to have quadratic. So if I was to multiply this, x squared minus x minus 6 is what it would look like, right? All right, but this is the factored form. This is where I want everything to be. Factored form, inequality 0. And that's where we want to start. All right? Once I get factored form, inequality 0, my question is, what makes each of these factors equal to 0? So x equals negative 2 and positive 3, right? So factored form, inequality 0. Find your x values where 0 happens. And then we simply want to create intervals all the way from negative infinity to positive infinity, stopping along the way at those numbers. So if I'm going to go along the number line, negative infinity lives right down here, positive infinity lives all the way up here, right? And I'm walking along the number line from negative infinity to positive infinity, and I get to negative 2, that's my first stopping point. So I'm going to go negative infinity, comma, negative 2. I always start here, and I stop at the first number that happens numerically here. And then I want to worry about parentheses and or brackets. So obviously parentheses at infinity, because I already told you that. Infinity is always a parentheses, because infinity is not a location, it's an idea. Go as far down that way as you possibly can. When you think you've gone far enough, keep going because you haven't gotten there yet. All right, that's where infinity is. All right, there's no specific spot there. Now, looking at the inequality symbol, this is greater than, not equal to, right? When it's greater than, not equal to, that means we don't want to include answers. We don't want to include zeros in our answers. So I'm going to put a parentheses also at negative 2 because we're not including that. All right? So from negative infinity to negative 2 is one region I need to investigate. The next region to investigate starts at negative 2, same idea. So parentheses here, parentheses there. If this was a bracket, that would be a bracket. So whatever that is, that's the same decision. And if I continue walking along the number line, the next number I hit is 3. So negative 2 comma 3. I'm still only greater than, not equal to, so it's a parentheses on 3 also. The next region I need to investigate starts at 3 with a parentheses, comma, and I've run out of numbers right there, right? So there's nothing to stop me now. I get all the way to infinity. Okay, so however many zeros you get, you're going to get one more region to investigate. Negative infinity to smallest number to next biggest number to next biggest number, next biggest number to next biggest number, and so on and so forth. So you run out of numbers, and then that last number to infinity. That's how you make all your regions. And what I want to ask myself is, if I pick a number between here and here, will this product be greater than or less than 0? That's what I want to ask myself. What am I multiplying together? How many things? 2 things. All right, so let me just use some different colors on each of these so we can see what's going on here. We'll do that one in red. We'll do this one in, let's go with that magenta color. Should have done this before. And I'll just keep that one blue. Okay. So here's what it looks like. I pick any number between negative infinity and negative 2. You ever play that game, pick a number between 1 and 10? Yep. Pick a number between negative infinity and negative 2. Negative what? Negative what? Say it.
3.
3, perfect, negative 3. I thought you said negative 2, that wasn't going to work, but negative 3 works. All right. Negative 5 million works, negative pi would work, if you felt like it. I don't want negative pi, but you can do it if you want to. That's between them. All right, any number between that will work. All right. And what I want to do is I want to evaluate this. Now, I don't care what the answer is, I care what the sign of the answer is. Okay, so here's what I do when I'm doing this. All I ask myself is, what sign will the number be? So if I do negative 3 plus 2, what kind of sign will we get? Negative. If I do negative 3 minus 3, what kind of sign do we get? Negative 3 minus 3 is negative, right? Negative 6. If you really want to know the number, it's negative 6. All right. Negative 3 minus 2 is negative 1. Negative 3 minus 3 is negative 6. 2 negatives, when you multiply, make a positive. We're looking for greater than 0, which is also known as positive, right? That's what greater than 0 means. Yep. So this product between negative infinity and negative 2, the product for that one specific number was positive. All that means is every number on that same interval is going to be positive, which means that's a correct answer to this problem. Every answer between negative infinity and negative 2 will make this true. Moving on to the next region, negative 2 to 3, we need to pick a number between negative 2 and 3. What do you want to pick? 1. 0 works, 1 works. I personally like to pick 0, because 0 is easy, but 1's fine. 1's easy too. So, pick 1. 1 plus 2 is positive 3. 1 minus 3 is negative 2. Positive times negative makes a negative, right? We're looking for positive, we found negative. So if I pick a number between negative 2 and 3, just like 1, I'm going to get a positive times negative makes a negative every time. That region does not work. Next region, I need to pick a number between 3 and infinity. 4 works. I could pick 77 if I felt like it. I don't want to, but 4 is fine. All right. 4 plus 2 is positive 6. 4 minus 3 is positive 1. Again, each time I'm just putting x, the value that I pick here is x. Put x in there, figure out what kind of answer I get. Positive times positive makes it positive, and we're looking for positive, so that works also. So this region and this region both create true statements for that inequality. So what I want to do is I want to graph both of those on this number line. If I want to graph negative infinity to negative 2, domain set of real numbers, all right? Negative 2 open circle because of the parentheses. Goes to negative infinity, so we shade off to infinity. Negative infinity it should be. Like so. And 3 comma infinity, open circle at 3, and we want to go towards infinity, so we shade towards infinity. Make that arrow bold, and there's your answer.